So here in the state package, let's add a new class, tool. In this class, we need two abstract methods. So public abstract void, mouse down, and mouse up. Now, because these methods are abstract, we should mark the class as abstract as well. Now, we could also use an interface here, because an interface is simply a contract that determines the capabilities that a class should provide. So earlier you saw that the methods in an interface don't have an implementation. They're exactly like our abstract methods here. Now, what is the difference between an interface and an abstract class? Well, they're both abstract concepts. We cannot instantiate them. We cannot create a new instance of this tool class or the tool interface. So because they're abstract and don't have much code, they allow us to build loosely coupled applications. We prefer to use an abstract class if we want to provide some common code to all the child classes. In this case, we're not providing any common code to our tools, so I'm going to replace this abstract class with an interface. Take a look. Public interface. Now in interfaces, we don't need the abstract keyword because these methods are considered abstract by default. So we remove the abstract keyword. Also, these methods are considered to be public, so we don't need the public keyword either. That makes our code cleaner. So we have an interface for representing a tool. Now, let's implement specific tools. So let's add a class called selection tool. Here we type implements tool. Now note that here we have two interfaces with the same name. The first one is the one that we just created. We also have a tool interface in JavaX package. Don't worry about that. Let's import the interface that we created. Okay. Now we should implement this interface. So we press Alt and Enter and implement these methods. So this is where we implement the logic. With the selection tool, when the user presses the mouse button, we should change the icon to the selection icon. And when they release the mouse button, we should draw a dashed rectangle. Okay, now let's add one more class. This one is going to be our brush tool. Brush tool also implements the tool interface. Here we have a different logic. So when the user presses the mouse button, we should display the brush icon. And when they release the mouse button, we should draw a line. Now let's see how we can incorporate these into our Canvas class. So let's open up the Canvas class. First, we should change the type of this field from tool type to tool. So we're programming to an interface, okay? Now we have a bunch of compilation errors. It doesn't matter. We're going to delete all the code in these methods. All this nasty, disgusting code. Now, we should change the return type of our getter. Instead of tool type, we're going to use tool. And similarly for our setter, we're going to pass a tool object. Beautiful. Now, in our mouse down method, we're going to call current tool dot mouse down. And similarly, here we call current tool dot mouse up. That's all we have to do. Isn't this code beautiful? So the Canvas class is simply delegating to a specific tool to determine what should happen when the user presses or releases the mouse button. With this implementation, we don't have a long list of decision-making statements, so our application is more maintainable. And we can also easily extend it. Let me show you. So right now, we only have two types of tools, a selection tool and a brush tool. Let's use this, and then I'll show you how to extend this application to support a new tool. So we go to our main class. First, we create a Canvas object. So Canvas. Now, we set the current tool, set current tool. Here we should pass an object that implements the tool interface. So we can pass a selection tool. Then we call mouse down and finally mouse up. Let's see what happens. So the icon changes to the selection icon, and then we draw a dashed rectangle. Beautiful. If we pass an instance of the brush tool class, we'll get different result. There you go. Now, let's say tomorrow we want to support a new tool. That's really easy. All we have to do is to add a new class that implements the tool interface. Take a look. So Here, I'm going to add a new class. Let's say eraser tool. We have this class, implement the tool interface. And over here, we implement our logic. So eraser icon. And here, erase something. Now, we go back to our main class and simply pass a new instance of the eraser tool class. Take a look. We get a different result. And that brings us to a very important principle in object-oriented programming, open-close principle. That basically means our classes should be open for extension, but closed for modification. So we're not allowed to change the code in our classes. We can only extend it. Now, with this principle, we can add new functionality without changing the existing code. We can support new functions by adding new classes. Now, why does this matter? Well, how many times have you found yourself changing the code in a class and then breaking something in your application? The open-close principle prevents situations like that. Every time we want to support a new feature, we simply add new classes and we test those classes, okay? So following this principle makes our applications extensible and robust. If this concept is new to you, don't worry, you're going to see more examples of this later in the course.